Hi, in this video I'm gonna talk about GCE A-level math with graph and transformation. And first we'll go through some of the concepts first, and then we'll start practice with some questions. Okay, so before we move on doing some questions, let's go through some of the concepts first. And this time I actually kind of want to explain the concept slightly further because I've recently received some of the comments from my friends telling me that I didn't explain enough before move on to do some questions. Okay, so for the first part of this summary of key points, if p is a root of the function f of x, then the graph of y equals to f of x touch or cross the x-axis at the point p comma 0. So basically, for the first part here, let's say if I have a graph like this, crossing 3 points, then the roots point are 1, 2, and 3. Or you can say that this point are actually also the critical value of x when the y is equals to 0. Okay, so this is y and this is x. Okay, so for the part 2, the graph of y equals to k over x and y equals to k over x squared, where the k is a real constant, have asymptote at x equals to 0 and y equals to 0. Okay, so the graph for y equals to k over x would look something like this. Let's say this one is y and this one is x, okay? 1 over x or k over x, whatever, k over x would look something like this. So asymptote is the line that the curve will never touch. So the asymptote with this case is y equals to 0 and x equals to 0 because these two lines are not touching any y-axis or x-axis. Okay, so for the part 3, the x-coordinate at the point of the intersection of the curve with the equation y equals to f of x and y equals to g of x are solution to the equation f of x and g f of x. I mean, that's pretty straightforward because when you want to find, let's say, y equals to, let's say, okay, I'm going to write here. Let's say y equals to x minus 3 or y equals to x squared minus x. Basically, if you want to find our x coordinates, you just have to substitute this y back into this y. Okay, for the part 4, the graph of y equals to f of x plus a is the translation of the graph y equals to f of x by the factor brackets 0 and a. Okay, so if you see this kind of case, 0 is x and a is y, and same as here, negative a is x and 0 is y. So what does that mean? What does plus a mean? So if you see the equation look like this, basically it's y equals to f of x move up or move down vertically with the a units. So let's say y equals to x minus 5 and 2x plus 3. So y would be equals to 2x squared plus 3x minus 10x minus 15. The next step would be 2x squared. 3 minus 10 would be minus 7x minus 15. So if we have to draw a graph of this equation here, okay, y, then it would look something like this. Because we already know that the critical value of x is 5 and minus 3 over 2. So this will be minus 3 over 2. And this one will be 5. This one here will be, I just substitute this x equals to 0 back in this equation, minus 15. Okay, so back to the concept for the part 4. If I say y equals to f of x plus a, substitute any number back to a. Let's say if I put plus 5, okay? So what does that mean? So if y equals to f of x is basically this equation here already. And plus 5, what does that mean? It means that the whole curve will move up to 5 units. So it will look something like this. The y-intercept would be minus 10. Okay, so what about if y equals to f of bracket x plus a? What should we do? Okay, so this one is slightly tricky. If you see this value here is positive, then you have to move the whole graph to the left. But if you see this value here is a negative value, then you will have to move the whole graph to the right. So now I'm gonna do two cases, okay? Let's say, okay, this one is part 5. Y equals to f. Let's say x minus 5. I'm gonna draw two graphs, okay? And y equals to f of x plus 5. So this one is y and this one is x. This one is y and this one is x. Okay, so if we see this kind of problems here, y equals to f of x minus 5, so we have to move the whole thing to the right. So the original critical value is minus 3 over 2 and 5. We have to move the whole thing 5 units to the right. So the curve will look something like this. This one would be minus 3 over 2 plus 5 would be 3 over 5. And this one here would be 5 plus 5 would be 10. And the same as here, if we have to move the whole thing to the left, it will look something like this. So if minus 3 over 2 minus 5 would be equals to minus 6 over 5, sorry, minus 6.5. And 5 minus 5 will be 0, so it will be here. Okay, so move on to part 6 here. When you translate a function and the asymptote are also translated. Yeah, so basically if you move the whole graph, the asymptote will move at the same time. And for part 7, the graph of y equals to a f of x is stretched of the graph y equals to f of x by the scale factor of a in a vertical direction. Yep, so okay, for the part 7, let's say if I substitute any number that is a. Let's say if I put y equals to f, 2f of x, then you basically vertically stretch it. So you make it looks taller. But if, let's say, y equals to 1 over 2 f of x, so everything with the y coordinate will have to divide it by 2. So what does that mean? You basically make it shorter. You basically shrink it. And for the part 8, it says the graph of y equals to f of ax is stretch of the graph y equals to f of x by the scale factor of 1 over a in a horizontal direction. Okay, so let's say y equals to f of 2x. Okay, it shrank horizontally. So it make it much narrower. And let's say if I say y equals to f of 1 over 2x, you basically make it wider. It stretch horizontally. Because when you substitute this 1 over 2 or 2 back into this formula, basically if a is equals to 2, then 1 over 2, you basically times all the x coordinate by 1 over 2. But if you substitute 1 over 2 back into this a value, then 1 over 0.5 will be equals to 2. So we basically times the whole x coordinate by 2. Okay, so last two concepts. The graph of y equals to minus f of x is a reflection of graph of y equals to f of x in the x-axis. Yeah, so if you see this kind of problems, y equals to minus f of x is times all the x coordinate by -1. And same as here, y equals to f of minus x is a reflection of graph of y equals to f of x in the x-axis. So yeah, let's say this graph here, x-axis is here, and y-axis is here, x-axis is here. You basically times the whole thing by -1, because negative x is actually -1x. This one here is actually y equals to f minus 1x. So if we substitute -1 back into a, 1 divided by -1 will be -1. So basically you have to times every x coordinate by -1. So what would that happen? You will just make a reflection of that graph in the y-axis. And yeah, that's pretty much it for the concept for this chapter. And let's move on to practice with some questions together. Okay, so let's practice with some questions now. This question here is actually from page 87 in the textbook. and this question carries 4 marks in total. So for the part A, they want us to sketch the curve with the equation y equals to minus f of x and y equals to f of 2x. So what should we do? We have to draw 2 graphs first. One is for part A and the other for part B. This one will be y, and this one will be x, and this one will be y, and this one will be x. So minus f of x, what does that mean? So this one here is equals to y equals to minus 1, okay, and f of x. So all you have to do is to times all the y coordinate with -1. So let's say this one here is originally 2 and 0, and this one here is 4, 0, and this one originally is 3 and -2, right? All you have to do is to, okay, this is x and this is y, times the y coordinate with -1. Every y coordinate by -1. So all you have to know is negative will convert to positive and positive will change to negative. So the graph should look something like this. And this one will be 3 and 2, but the x will be the same, so the curve should look something like this. Okay, so for the part B, f equals to f of 2x. So what does that mean? Basically, times all x coordinate by 1 over this value here, 1 over 2. So this point is originally 2, 0 and 4, 0. If I times the x coordinate by 1 over 2, then this one here would be 1 and 0. And this one here would be 2 and 0, because 4 divided by 2 and 2 divided by 2, the point P would be 3 over 2, and I'm not gonna touch y coordinate, so it would be -2. So the curve should look something like this, and the point here would be 1, and the point here would be 2, and the point here would be 3 over 2 and -2. So I basically straighten the whole graph horizontally. Okay, let's move on to the next question, 27, and this one is in page 87. Okay, so for part A, what do they want us to do is to sketch the graph of this tree, similar as the previous question. Okay, so I'm gonna do it in fast-paced. This one is for part A, part B, and part C. Okay, x and y, and x, y, and x, y. Okay, so x plus 1. So I have to move the graph to the left by 1 unit. So if I move all the x coordinate to the left by 1 unit, so the curve should actually look like this. And this one will be 3, because 4 minus 1 will be 3, and here will be 0. Because 1 minus 1 will be equals to 0. Okay, for the part B, it says 2 times f of x. So all you have to do is to times all the y coordinate by 2. Let's say here the y coordinate would be 3, right? And x coordinate would be 0. But here, the y coordinate would be 0, but the x coordinate would be 1. And same as here, the x coordinate would be 4, and y coordinate would be 0. Okay, so all we have to do is to scratch the graph vertically. So it will be something look like this. But the coordinate will be slightly different. This one here would be 6, because 3 times 2 would be 6. But here would remain the same. X coordinate will be 1 and 0, and here as well. 4 and 0, because 0 times 2 will be equals to 0 as well. Okay, so for part C, it tells us to sketch the curve of y equals to f of 1 over 2x. So what do we have to do? All we have to do is to times all the x coordinate by 1 over 2, which is 2, times all the x coordinate value by 2. So here's the curve, but this curve is slightly wider. Therefore, the coordinate would be 1 times 2 would be equals to 2, and 4 times 2 would be equals to 8. And for the y coordinate, it remains the same. So it will be something look like this. And here's the answer for part A, B, and C. Okay, let's try to do these questions. This actually is also from page 88 in the textbook. And for the part A, they want us to sketch the graph of y equals to f of x plus 3. So what does that mean? So f of x is 1 over x, right? 1 over x would be something like this. This one is y, this one is x. 1 over x would look something like this. And the curve is not touching x equals to 0 or y equals to 0. But they want us to sketch f of x plus 3. So what does that mean? So basically the whole curve move up 3 units. So that will become, this one would be y and this one will be x. All I have to do is to move the whole graph up 3 units. So the asymptote would be right here. Y equals to 3. The curve should look something like this. And the curve is not touching the asymptote. So yeah, that's the graph for part A. And for part B, they want us to find the coordinates of points where y equals to f of x plus 3 cross the coordinate. Okay, so the only points that they are crossing is this one here. So if I assume that y is equals to 0, then I can get to find the x. When y equals to 0, 0 equals to 1 over x plus 3. And 1 over x would be equals to negative 3. X would be equals to minus 1 over 3. And the coordinate would be minus 1 over 3 and 0. And that would be the answer for question 28. Okay, let's try this. This one is also in page 88 in the textbook. So let's start off with part A. This time, they want us to state the coordinate of the points. They don't want us to sketch. So they want us to write down the point which P is transformed on the graph with the equation below, ABC. Okay, so for the part A, it is negative. So what I have to do is to times all the y coordinate by negative 1. For the point here, 6 and negative 8, right? So if I times all the y coordinate by negative 1, this one is x and this one is y. So if I times this one by negative 1 would be 6 and 8. Okay, for the part B, y equals to f of x minus 3. So what does that mean? It means that the whole curve moved to the right by 3 units. So x coordinate plus 3. So if this one is 6 and negative 8, then this one x and y, all I have to do is to 6 plus 8, which would be 9 and negative 8. Okay, for the part C, 2y is equals to f of x. So if I divided both sides by 2, 2y equals to f of x. If I divide it by 2, both sides, y equals 1 over 2 f of x. It means that 1 over 2 times all the y coordinate. So if this one here is 6 and negative 8, all I have to do is to times minus 8 by 1 over 2, which would be minus 4. And that would be the final answer for part A and B and C. Okay, let's do one more questions here and then we'll move on to do some past paper. Okay, so for part A here, they want us to sketch the graph of y equals to 1 over x squared minus 4. So first thing first we have to do is to sketch the graph of y equals to 1 over x squared first. And then we'll basically move the whole thing 4 units downwards. This one is y and this one is x. So this one here would be 1 over x squared. Now, y equals to 1 over x squared minus 4. From there, we will have to move the whole thing 4 units downwards. So it would be something look like this. Y and x. So the asymptote would be negative 4. Y equals to minus 4. Okay, so the curve should look something like this. Yep. and the curve here is not touching the asymptote. Okay, so for the part B, they want us to find two possible value of k when the curve with this equation here pass through the origin. Okay, so the keywords here is when pass through the origin. So basically when y is equals to 0, x will be equals to 0. So if we substitute back these two values into this equation, 0 will be equals to 1 over 0 plus k squared minus 4. The next step would be 4 equals to 1 over k squared, because 0 plus k would be k squared. From there, we times k squared to the both sides would be 4k squared equals to 1. And k squared would be equals to 1 over 4. The final answer would be k equals to plus or minus 1 over 2. And that would be the final answer for part B. Okay, let's take a break now and then we'll move on to past paper later.